Okay, all right. So here we are today. Today we're in our lesson. We're going to talk about radical equations. So some of you are probably thinking, "Wait, what's a radical equation?" And so that's what we're going to find out today. We're going to practice a little bit, and that's it. Okay, all right. Let's get started. Okay, all right. So you should write this down. All right. So radical equation. So it looks like we're talking about square roots again. All right. And this time we're combining unit 1 and unit 2 together. So let's take a look. Now let me give you a couple of examples first. All right, so this is the premise of a radical equation. Think about it like this, right? Now, in class, so far this year, we talked about, let's say if I give you 7 squared, right? What's 7 squared? Right, 49, or if I give you 10 squared, right, what would that be? Yeah, 100, right? So a radical equation, it's a question that sounds something like this, right? Now look at this. Here I got the square root of x equals 5. So the fundamental question is, what's the square root of what will give you 5? Think about that. The square root of what will give you 5? Yeah, 25, right? Because the square root of 25 is 5, right? So what is x? X is 25. Right? And that's it. That's a radical equation, right? And look at it, right? We are looking at it as an equation, right? X equals 5. The square root of x equals 5. Now remember, right? In algebra, we know we're finished when we have one letter equaling to one number, right? And in this case, right, the square root is no good. We don't want square root of x. I just want x. I don't want the square root on the top. So here's the question, right? If we were to solve it as a bona fide equation, what would we need to do then? Because remember in equations, right, when we do like one-step or two-step equations, we always what? We always either add on both sides of the equal sign, we subtract on both sides, or we multiply on both sides, right? Sometimes divide on both sides. So what is there to do here? Because so imagine if you got a huge number, right? Square root of x equals to, I don't know, like a really big number. Okay, what would we have to do then? All right, and here's the trick. Here's what you would have to do. You would have to square the square root. So think about it like this, right? If I have the square root of 10 times the square root of 10, do you remember what the answer was? Yeah, it's square root of 100, which really is, what's the square root of 100? Yeah, it's just 10. In other words, right, remember that when we take a square root of a number multiplied by itself, all we have to do is get rid of that radical symbol, right, to get 10. So we are actually doing that. That's exactly what we're doing. What we're saying is, hey, if I raise the square root to a second power, what I have really is this. Let me write that out for you. We have the square root of x times the square root of x. Now, what's the square root of x times the square root of x? Yeah, it's just x, right? Remember what I just said, right? Take the symbol away, right? So now, remember, right, with equations, what we do on the left side of the equal sign, we have to do on the right side of the equal sign. So what does that mean? That means, right, when we get this, when we square the square root, right, it's just x. What's 5 times 5? Yeah, 25. Wasn't that the answer earlier, right? The square root of 25 is 5. Right? Now, with that said, why don't you try this one on your own? What would the answer be? Okay, all right. So you square the square root, right? I know the language might sound confusing. Okay, so you have. I'm trying to speak very carefully here too. So that now the square root of x squared, right? That means square root of x times the square root of x, right? Because that's what a second power means, right? That's x. So that's good. Good. We're on the right track. 9 squared, 81. Okay, and that's how you do it. Now, some of you might say, like, wait, is that it? You know, is that all we have to know? And my answer is not quite. Okay, so what is there to do, right, with these sort of questions? So let me show you another example. So here we have the square root of 2x plus 9, right, the whole thing equals 5. Same thing. Don't get intimidated by these large expressions or equations. Okay, same thing. Right? Now, all I need to care right now is that if I take this whole thing in the square root and I square it, all I'm left with is this, That's all we need to know. Like this whole thing is gone. Okay, and we love this. Now, what's 5 times 5? Right, 25. So, oh look, we have a two-step equation to solve here. So that's 2x. Now, is that 16? Yeah, that's 16, right? Divide both sides by 2. Cancels out. X is, right? What is that? That's 8. And that's it. Now, how do you, hey, by the way, so how do you know if your answer is right? Yeah, you substitute, right? You can check, right? So I got 2 times 8 plus 9, right? What is that? That is 16 plus 9. That is square root of 25. Is the square root of 25 equals to 5? You bet. And that's how you do it. Okay? So let's try another one, right? Now, if you want to, you can press pause and try these on your own, even though I have Regents questions for you after. So why don't we do a couple more of these? All right? We don't even have... No, actually, you know what? I want to show you all of these. Okay, you know, if you want to try this one on your own, okay? All right. So press pause if you want to. Okay, all right, so here I'm going to square it. Now, the only difference is the v is on the other side of the equal sign. That's all this is. So this is 36. V minus 2, right? Remember what I said? All right, now we got rid of that radical. Add 2. Add 2. V equals to 38. Okay? Not so bad, right? Now, I want to show you this. So this is another step up. So like, think about this, right? This is first step. This is the second step. Now we're on the third step. The third step is something like this. Now, look at this. How is this third question? Not really third question. How is this third step different than the step 2? Look at this. What's the difference? Yeah. Right? Like there's like this number that's hanging out here. Now, be very careful. You can't just square the whole thing like this. Like that's not the point. All right? The point is to move the 3 to the other side first. Now, I think you all are very adapted at moving constants and variables around now, right? So what would you do? How would you get this out of the way to the other side? Yeah, you subtract it, right? Perfect way out. So this cancels out. I'm left with this, right? 0 minus 3 is negative 3. See that? Right? And now I can do my thing. I could take the square root. Take the square, sorry. Take the square on both sides. So all I'm left with here is 4x minus 7 equals to negative 3 times negative 3. That's positive 9. 4x minus 7 equals 9 plus 7. All right, cancels out. 4x equals to 16. Divided both sides by 4. X is 4. Okay? All right, my writing instrument is very slow all of a sudden. Okay, all right, hold on. I gotta press pause. I gotta turn the lights on again. Now, if you're feeling adventurous, you can stop this video and try this one right now. Okay? Alrighty. So, let's try it. Now here, slightly different, but not really. So in other words, by the way, I want to summarize real quick. The goal is to isolate the square root. Right? So this is isolated, this is isolated, this was isolated, this was isolated. This wasn't isolated, right? Because of the 3, but down here, after the first step, this was isolated. So same thing here. I want to isolate the radical 3x. So that cancels out. I bring down radical 3x. 7 minus 2, that's 5, right? So I isolated the square root. So now I square it. So that's 3x. That's 25. Is that right? Oh, it's going to be some weird fraction. Okay. Okay, and that's that. All right, one last one. All right. Why don't you try this one? Okay, so press pause and try this on your own. Okay, all right, and we're back. So let's add 8 again, isolating the radical. What's that, 5, right? Square it, square the square root, right? So this is 5a minus 5 equals to 25 plus 5. 5 equals to 30 divided by 5. A is 6. Okay? All right. Now, these are the questions from the regions. So, I would like you to challenge yourself and try these, actually. Okay? Give it a try. I want to see how much you've learned from just this very short lesson alone. Yeah. Okay, so press pause right now. When you come back, I'm going to show you the answers. Okay? So, press pause right now. Okay, and we're back. Now, the only thing I want to point out down here is be careful down here. I had to double check for this one because it says -3 and then there's another -3 inside the radical. So be careful there, okay? Yeah, just be a little bit more careful there. Okay, now I think I got 3 more questions for you. Let's see. Oh, only 2 more. Okay, all right. So press pause. Now this one's a great question. Okay, so yeah, all right. Give that a really good try, okay? All right, press pause right now. Okay, all right, and we're back. Now, this one's a crazy question. Only because, you notice how there are no numbers here, right? They're only letters. So we're gonna get to that in a little bit. In about a week, we're gonna talk about what we call literal equations, where we're solving equations with nothing but letters. Okay, so this is just like a preview. So here, right, I squared both sides. Now, I'm hoping that you would know that b squared means b to the second power means b squared, right? And then I just add a on both sides. And that's how I arrived at that. Now, look at this thing here. What does this all mean? Why does why does this number has to be greater than a? Think about that. Think about this, right? If x was a 5 and a was a 10, what's the problem here? Remember when I said this was like almost a month ago now? Yeah, not a real number. This is an imaginary number. Right now, in the 9th grade, you can't do that. Not yet. Not yet. You will one day. All right? Right now, we're not dealing with imaginary numbers. We're only dealing with real numbers. So the problem with if x is not greater than a is that you're going to get a negative number, which, you know, throws everything off. Like, they can't even ask you a proper question on the regions. So that's why they have to, like, have a disclaimer, so to speak. Now, same thing here. What on earth are they talking about? Like, if x is a real number, right? If it's not real, what is it again? Yeah, imaginary. So again, they're trying to, like, you know, kind of make sure that you know that, you know, for those of you who know imaginary numbers already, that, you know, they're not trying to trick you, okay? X has to be a real number. It cannot be imaginary, okay? Now, with these brackets, don't worry about it. We're going to talk about the set notations next week, okay? Or in the next couple of days. And that's it. Okay, all right, I'm going to wrap this up, all right? Yeah, not bad. Okay, all right, thanks for watching. Have a good day.
OMG, that was so good.